Hello everyone and welcome to our today's Vaadin webinar. Today we are talking about JPA and best practices, how you can use JPA in Vaadin applications. But most of the stuff that we will be covering today is it's not that much Vaadin related, but more JPA related. And we will be here with Mattsson from our service department. So what are you actually doing here in Vaadin?
I'm a senior Vaadin expert. I work as a project manager in our services department. So
And that sometimes involves some JPA coding as well?
Sometimes, yes, some JPA.
Yeah, so not only just some Vaadin development, but making like full architectures for our customers. Let me put my mobile phone off so it doesn't disturb us. Sorry about that.
Maybe a good idea.
Okay, so this is our today's agenda. So we are talking about mapping, entity manager, and transactions, how you should use those, and how you should probably use some kind of service class, implement some kind of data access object or repository pattern,
Yes.
and usage examples from UI to backend. So practically we have one example application that we will be using. I can actually show it here. What does it look like? So this is our example application. So very simple CRUD application, but it uses JPA layer behind the scenes, and it uses JPA layer in a way that you can actually approve as well.
Yes.
So not in some bad ways at all. So it has two entities. It has phone book group entity, and then in the main view we have like the phone book entry. I think that's the entity name.
Yeah.
So practically names and numbers and different kind of addresses that you can type in. So you can type my work address here, Ruukinkatu, if you happen to need to know where to come to find the best Vaadin experts, like that. And then you can adjust some relations between the entities and such. And we'll practically go through the whole code of this application, and that should give you pretty good kind of a starting point how you can use JPA in your Vaadin applications.
Yes.
So, Thomas, we also have this JPA container in Vaadin.
We do, yes.
Have you used that in your projects?
Well, I've been doing JPA projects for 6 or 7 years now, and I have never once used JPA container in any of them.
Okay, yeah. Did you listen to that? So, practically JPA container, it's a product that you can use in a simple applications where you just list some entities, but in most like real life applications you will also need some business logic, and then you will need some more complex setups where you have relations between tables and you need to edit those, and things will get very complicated with that simple setup.
Definitely.
So most often, even in pretty simple cases where you start from, you should use this kind of approach where you have some kind of service class and bind that directly to your Vaadin application.
Yes, definitely. So the JPA container might be useful if you're using a table or a grid component in a very, very isolated, simple admin interface, for instance.
So you want to list some kind of one single table from the database.
But even then, typically you build your admin interface into the rest of the application, and the rest of your application should use something else. So you might as well use the same pattern everywhere.
Yes, exactly. And this kind of pattern that we present here, that kind of also hides the JPA stuff completely from the UI layer.
Yeah.
We will be actually using the JPA entities also in the UI code.
We will, but that's not typically a problem with Vaadin applications.
Yeah, and JPA, they just contain some annotations that are from JPA library, but typically you get those anyway for your UI code layer. So
exactly.
How can you kind of overcome this issue if you don't want to use any JPA?
Well, you can use DTOs, for instance. So your business layer works with the entities, fetches them and stores them. And then in your business layer also translates those to DTOs. So you might, for instance, make separate DTOs for each of your views. Yeah. And those will be just normal POJOs without any sort of JPA connectivity.
So this will kind of increase the complexity, but it will also make it more versatile in some cases. Sometimes you can like have different kind of DTO at the UI layer than you have actually in the backend.
Yeah, exactly. You can combine the data from multiple entities to a single DTO depending on what you need in your view, and then it's much easier to change just the backend implementation. If the service you get one entity from changes, for instance, you don't need to worry about it in the view at all. You just change the way you construct the DTO.
But in typical small or medium-sized application, it's just a good habit also to use the entities.
I would recommend using that. I typically start from the entities, and very seldom do I need to use anything more complicated.
If you have a specific case where you need different kind of DTO for the UI, then you can just implement different kind of method to your service object and use these DTOs for UI layer.
Exactly. Start simple and then build as you need more complexity, but not before.
Okay, let's start from the entity classes and mapping part.
Sure.
So how we have done that in this example. So let's start from the phone book entry.
Yeah.
So this class represents one table or one row of a table.
Yeah, so for those of you familiar with JPA, this will be pretty much standard, but just a really short go through for those of you who haven't used JPA before. I would really recommend reading some tutorials online. There's lots of them.
We will not cover everything in this webinar, just a kind of a small, very small quick through. With these entities, so that if you haven't used JPA, then you can follow the whole webinar and see how we are.
Yeah, so just a short overview here. We have our small address book demo application, and we have two packages. So org.example, which contains the UI stuff here, so you can see the UI class, for instance, and then the backend package, which has all our data and data access stuff. So in here we have two entities. We have the phone book entry entity, and then the phone book group entity. These are just normal Java classes, both of them. So both of these are now mapped to their own database table, which means that phone book entry will get its own database table, and so will phone book group. And JPA will automatically translate the queries to store a phone book entry, so mapping each of the columns down to the specific column in the database. Mapping between the field here and the column in the database. Yeah.
So what's in the abstract entity?
Yeah, both of these extend abstract entity, and this is a very typical pattern in JPA because there's a couple of fundamental things in JPA entities that you should always implement. One is the ID for each entity, and another one is the version, which isn't necessarily needed, but it's very recommended.
So where is this version needed?
That's needed for optimistic locking, and we'll get back to it a little bit later on.
Yeah.
But let's start with the ID. So since we're using databases and relational databases, we need a primary key for each table. And in JPA speak, this is the ID of the entity. And since all entities have an ID, then we might as well put it here in the abstract superclass. So we have a long field here, ID, and this now gets populated by JPA when we store something, store an entity here, for instance. So just a couple of words about the annotations that we use to enable JPA on these classes. Mapped superclass means in JPA speak a superclass that has some relevant fields. So basically also scan this parent class for any fields that might be needed in the database table. Then the ID annotation, pretty straightforward. Then we have this generated value, which is set to auto. And this means that JPA will actually generate the ID for us. We don't need to generate a running number ourselves, but
so we don't need to assign it before we save it with JPA.
So, and we shouldn't actually assign this at all anywhere. We should always just let JPA handle it. We can read it, of course, but we shouldn't set it ourselves.
So what's the strategy? You have auto table there, but what kind of different kind of other strategies do you have?
Well, there's quite a bit of different things. So, and these depend a little bit as well on the JPA implementation that you're using and the database implementation that you're using. Auto just is full automatic, and you don't have to worry about it at all.
So the JPA implementation decides how it will kind of generate this.
And then there's 3 other choices: identity, sequence, and table. You can read about these in the documentation. Basically, normally you only need auto, but if you need some special sort of features, then you can choose another, but we'll not go deeply into that. It's not really relevant for the demo here.
Yeah.
But another thing that actually is relevant, especially since we're going to use these entities in the UI layer, is what we have underneath here. So we have equals and hash code implemented.
Those nasty methods that are very easy to implement in a wrong way.
Yes, exactly. Even though you can basically copy paste this thing from everywhere and it should be correct all the time. But just 3 weeks ago, I made a bug in one of my equals methods and I didn't catch it.
So these are very essential because you will want to use these entities in basic Java collections.
Yes.
List sets, hash maps.
So equals and hash code are very, very important Java methods, and without them, collections, especially collections based on hashing, for instance, hash map or hash set, will not be able to find your entities again, or they might report the wrong sizes, or the iterators might be wrong. Yeah. Also, Vaadin components, and especially the Vaadin containers, will use these methods.
Or they are using it through basic Java util collections. Yes.
So if you create a collection and then a container of these entities and pass it to a Vaadin grid, for instance, then you might get some weird behavior if you have not implemented these correctly.
So what do you think? Is this like a perfect solution now?
Well, the equals method seems pretty okay to me. So it has all the 3 things that you need. You need to check for this, and then we check if it's not yet stored. So if this is a transient entity, we just created it, of course, then it's unique and it can't be equal to anything else.
Yeah, then you can use the object tracer.
Yes, exactly. And otherwise we check the ID of the object. So even though we have 2 actual objects of the same thing, if they have the same ID, then they are identically the same. Yes. Java might create multiple objects of the same database row, but it's the database row that's important here. Yeah. And then hash code. This one is a little bit more controversial because you can do multiple different things here. In this particular example, we've just decided that we will calculate a hash code ourselves using a couple of prime numbers and multiplication. And this is usually...
And the identifier.
Yes, exactly. So it's always based on the identifier. This might be null, but in this implementation that doesn't matter. It's still a valid hash code. And the only thing that this needs to do, the hash code method, is to not change after we've saved or stored the entity.
So the only place where this hash code method doesn't work is when you have non-stored entities and stored entities in the same collection.
Yes.
That happens very rarely.
Yes.
But if that happens, then you have some problems.
Yeah.
How would you actually write a different kind of implementation if you wouldn't have, if you would have this kind of situations? Would you just use DTOs with a different kind of hash
I probably would, that would become much more complicated. Yeah. The problem is that unstored objects need to use the object identity or the object hash code somehow, and then stored entities usually rely on the ID. Yeah. And object hash code, the normal superclass version, doesn't really work after you've stored it. Since I said you can have multiple objects with the same ID, and those need to have the same hash code, so you need to base it on the ID.
I think I have seen like one only perfect solution, but it's very complex. Then you would have to have like 2 different kind of IDs. You would have object IDs, where you would assign a UID, like a unique identifier there, so and then have a special different kind of database ID on a side, and that would be kind of fast on the database level, and still you would have a perfect equals and hash code methods. But I rarely don't see why would you really actually need that.
I haven't needed it for a single project so far. So something like this is going to be good enough for 99% of all cases, I would say.
Okay, let's go back to the phone book entry. So some real fields where we actually store the relevant data.
Yeah, so let's start with the entity annotation here. So all entities that you use with JPA need to have this entity annotation. That way JPA knows that, okay, this is a main data class.
Yeah.
And it knows to process the fields in that class. We've also defined a named query for this particular entity, which we'll get to later. But basically you can specify a query that gets then compiled to a named query. Depending on your database solution, that will result in different things, but it's one easy way to predefine queries for this data.
Yeah, but we have actually better ways to use queries. So
this is just
we
for
are
an
probably
example here.
we are actually not using that in the application, but just there for documentation purposes.
But yeah, let's take a look at the fields. So we have some string fields here, and we have a date field here, and we have a Boolean field, and then we have some more complicated stuff down below. But let's go in order. So we have a name field, a number field, and an email field. They're all strings, and JPA doesn't need any specific definitions for string fields. It just translates them into text, and then it can store it automatically. We don't need to worry about that at all from the mapping.
So what about these annotations? Those are like Java validation API?
Yes, these are not the JPA annotations. These are bean validation annotations. So we can annotate that this should not be null. This field is not allowed to be null when we store the entity.
But JPA implementations are smart enough to read those as well.
Yes, it is. So it can actually, if you generate the database using JPA, it actually takes these into account as well and makes constraints on the actual database table, which is quite handy in many cases. So we have a couple of different annotations here. We have not null and we have size, so the length of the field with the error messages if these should fail. We also have a pattern for the email address, as you can see here.
So that's just a regular expression that... Yeah. And then you can as well use own validators, but will not go to validation API in this case.
No. But then to some actual JPA annotations. So we have a date field here, and date fields are a little bit more complicated than just string fields. So you actually have
numbers.
Or numbers, yes. Date fields actually need this temporal annotation here, which tells Java that this is a temporal field of some sort, and you have to specify which sort it is. So in this case, since it's a birth date, we have it as a date. But you could also select only time, which would be time of day. For instance, let's say your shift in the morning always starts at 8 o'clock, then you can define just
and then the
time.
actual database type changes as well.
Yes, and then the third part is timestamp, which is combination of date and time. Then we have a Boolean.
Can you actually use Java 8 date with JPA?
Good question. It does not work out of the box, unfortunately. I don't really know why, but that's up to the Java developers. And
that's because Java 8 was published much later than JPA 2, so that's the issue.
Yeah, the problem
but
is
with
that
JPA 2.1 you can actually use converters.
You can, So
and then you can use that.
Yeah, so basically what you need to do is you use the normal Java 8 dates, so local date and local time in your code, and then you annotate converters on your entities.
And then you implement this converter on your own.
So there's lots of examples how you convert a local date to a normal date object that JPA can then handle. So it's not that difficult, but you have to do a little bit of a workaround.
Yeah.
All right, Boolean field, there's no annotations on this at all because it's not needed. JPA understands it out of the box. But then let's take a look at a little bit more complicated stuff. So we're not going to go deep into mapping with JPA entities at all because it can fill a book, and in fact it has filled several books. So we're not going to spend too much time on it. But just as an example here, every phone book entry can be part of several groups. Phone book groups here. So we have a collection, in this case a set, of the type phone book group. And this phone book group is its own entity. And we can now map these two entities, so phone book entry and phone book group, using this many-to-many annotation. This basically tells JPA that it needs to generate mapping on the database level between these two objects. So phone book group might have multiple phone book entries, and phone book entry can have multiple phone book group entities. So it's a many-to-many relationship. There are other ones, so as one-to-many, which is just that one phone book entry could have multiple phone book groups, but not the other way around. And then annotated on the other side, there's many-to-one as well. And there's also one-to-one.
Yeah, you seem to have this fetch type there as well. What do you think about that?
Yeah, we're going to talk about fetching collections a little bit later on, but just as an example here, this annotation here says that every time we load a phone book entry, we should load all these phone book group objects as well. So this group needs to be populated every time we load this entry from the database. Fetch type eager is an easy solution to make that happen, but it's always not a good solution to it.
Yeah, because of performance.
Yeah,
it will generate extra queries. So
it will definitely.
This is practically the source of this n+1 query problem that typically happens with JPA, especially with those developers who don't really understand that there really is this database behind the JPA. So with JPA, when you're developing JPA applications, you should always think about the database as well. It cannot completely abstract away the relational database behind the scenes. So
no, unfortunately not, even though that would be nice.
Yes.
But yeah, so a lot of people just say that, okay, I don't want to deal with these sorts of lazy loading issues or making sure that I always have fetched everything or have the data that I need. So we'll just make everything eager. And this is probably the cause of about 80 to 90% of all JPA performance issues that people are using.
It's not an issue in all cases, but when you have lots of data in your database, it will become a problem probably.
Yes. So by default, this fetch is not eager, it's actually lazy, and that's what I recommend you start with as well.
Exactly.
And then we have the last one here, element collection. As you can see, this field is also a collection. Here we have a list of phone book addresses.
But these are not entities.
No, phone book address is not an entity. It's normal Java POJO. We can actually take a quick look at it. It's embeddable here. That's a JPA annotation. That doesn't make this an entity, but it makes it JPA aware.
Yeah.
And then when we have a list of this, since it's not an entity class, we can't use one-to-many or many-to-many, but we can use element collection instead. And this is the same annotation that you would use, for instance, if you had a list of strings or a list of some enums or something.
Yeah. So practically this is like one-to-many annotation, but the other side is not an entity, so it cannot be referenced from anywhere else. Exactly. So these phone book addresses only belong to this one person.
Yes, exactly.
Yeah.
And then the very last thing, very important, always have an empty constructor in all of your entities, because otherwise JPA will throw lots of errors at you.
Yeah. And the rest of the class is pretty much just the getters and setters.
Yes, so there's just getters and setters here. We don't need to go through them. Phone book group, much of the same thing, except here we only have a string with no annotations or no validations.
So that's a very simple entity.
Yes.
Okay, but how do you actually use JPA in your applications? How do you pick up the JPA implementations? There are lots of different JPA implementations. OpenJPA, Hibernate is probably the most used one, and then Eclipse Links, that's a very good one.
Yep.
How do you choose your JPA implementation in project if you have one?
In projects, we typically start with what server are we going to run on.
Yes, so exactly. So you are using Java EE typically?
Yes, typically we use Java EE, yes, or at least the projects that I'm running happen to use Java EE most of the time.
Yeah, and Java EE provides you JPA, so you don't need to configure anything for your application.
So we take a Java EE server such as Wildfly and then run the project on it. And if we use Wildfly, then Wildfly provides Hibernate out of the box. So we might as well use Hibernate because that's easier.
Yeah.
If we use something like TomEE, then we get to choose our own because TomEE doesn't provide us.
TomEE has OpenJPA.
Okay, so that's been changed. But Yes.
In plain Tomcat, you don't have any JPA,
no,
but
exactly.
Tommy is like a Java EE server, and there we go.
So it's basically tied to the server on what you're going to use. So you can still override it and you can provide your own. So in Wildfly, we could configure not to use Hibernate, but use Eclipse Link instead.
Yeah.
But that's typically more work than it's worth doing.
Yeah. And also in Spring applications, there you typically, if you are using, for example, Spring Boot, then you automatically get Hibernate there.
Yeah. So typically you don't choose the JPA provider yourself. You choose something else which
so you
then
kind of
provides
choose
you with
some kind of application stack where you will be starting building, and then that stack will give you the JPA implementation.
Exactly.
Yes. And another important question is how to manage transactions in your application.
There are two ways to do it. One is do it yourself, and the second one is let the server do it for you.
Yeah.
I really strongly recommend letting the server do it for you.
That's probably the easiest place where you can break your application. Try to tackle the transactions yourself and then do it wrong in some place, and then the problems will just start.
Java EE provides you a very, very good API for transactions. It's completely transparent. You don't need to do anything regarding transactions yourself. You only need to tell it to use the built-in transactions.
Yeah. And
Spring has the exact same thing.
Yes.
So
in Java EE, the simplest way is probably used lightweight AGBs. So in AGB 3, they are really simple to do.
Yeah.
Yeah. So let's look at our AGB in this, I think it's phone book service.
Phone book service, yes. So in this particular example, we're using Java EE stack. So we have a stateless EGB here that is basically the gateway to all of our database things.
Yeah.
And nothing outside this class knows that we're using JPA, well, except the entities, but none of our Java code on the client or the UI side knows anything about JPA.
And there you have this annotation persistency contexts,
yes,
which injects you the entity manager, which is kind of the key place, or that's what you are actually using when you are using raw JPA.
Exactly. So it's the starting point. And then you can call em.persist, for instance, or em.remove and so forth.
Make queries and stuff like that with entity manager. And then you will need, at least in some cases, you will also need persistency XML.
Yes, so let's take a quick look at that. I'll show you the source here. Persistence XML, there's a lot of things that you can configure here. We're not going to go through all of them. But the two main things that you need is the name of the persistent unit that needs to be unique, and then the transaction type. And JTA here means that we're using the Java transaction API, letting the server do transactions for us.
Yeah.
And then all of these other things are just different properties to configure how JPA behaves. A lot of this is just logging. So for instance, we set the logging level to fine, we output SQL and so forth.
Yeah. And we also force the JPA implementation to create the database schema there.
So that's the first thing here. We have a drop and create setting for the schema generation, which basically in development time, it drops the database and creates it every time you restart the server.
And most often you also need this data source defined there.
So here is the JTA data source. This uses the JBoss format, so a data source that's configured in the JBoss or Wildfly standalone.xml file.
But in this case, we have just commented it out, and because of the nice conventions in Java EE 7, it automatically creates us one for the demo application. So but if we want to actually persist to some database, we need to configure the database connection in the service server, and then use the same. And that's it.
Yeah. So we're just using an in-memory database for this app now.
Okay. Let's go back to the service class. And there you also have this phone book repository. So what's that?
I do. So just using JPA is all well and good, but there's a lot of boilerplate that you have to write in many cases. And there are libraries that will help you.
A lot,
yes.
I have actually came to these libraries lately. Just like 2 years ago, I found Spring Data. That's
me too.
like very, very nice library that will pretty much I don't have to touch the entity manager almost never anymore. And then actually after that, I started to use JPA again in my examples. Before that, I tried to avoid JPA altogether.
I remember those times where it was really troublesome to just create queries yourself, and you had to do lots of extra stuff, a lot of repeating stuff as well.
Yeah. So these repository methods, so this is using Deltaspike data in this case because we are working in Java EE environment.
Yeah.
So it's pretty much the same kind of library as Spring Data, but works on plain CDI.
Yeah. So basically, what this does is it wraps the entity manager and all JPA stuff behind a repository class, which is auto-generated for us.
Yeah.
We only need to define a couple of things, and then all of the save methods, remove methods, find methods are all generated automatically.
So typically, you have like one repository for each entity type, and then you will get the like the basic CRUD methods for free.
Yeah. So
and then you can extend it.
Exactly. So in this example, we're using two different methods to access the underlying data, just for demo purposes.
Yeah.
The entity manager here is used directly to fetch phone book groups, and you can see some of the methods here, and we'll show you them a little bit later on. And then we have the phone book entry repository, which is a repository generated by Deltaspike that we use to fetch the actual entry objects.
Yeah.
So let's take a quick look at that. It's actually an interface annotated with the repository annotation here. And then we have defined a couple of methods. So find by name, like ignore case. Sounds a little bit strange, but there's actually a logic to this. Find by name is probably easier to start with. So find by is a keyword for Deltaspike, meaning find phone book entries, because this is a phone book entry repository.
By a property name.
Yes, by a property called name, and then we provide a string here. And then Deltaspike automatically knows that, oh, there is actually a property called name in our phone book entry, and then it creates all the queries for you automatically. Exactly. And when you inject one of these repositories, you can directly call any of these methods, and they will
or the ones which are inherited from the
exactly. So the entity repository provides persist, list, or find all methods, and save and then delete and so forth for you.
Okay, let's go through some of the usage examples so that we will start from the actual UI layer. So then we can see. So we could first maybe look at the main view, and there we have this listing of all entries.
Yeah, so let's just quickly show what it is. So it's this view that we have here. So we have a listing of entries here on the left and listing of groups.
So
here
if you
on the
start
right.
to build your UI for application, this is probably where you start. You list your existing database.
So let's take a look at how we do that. Not to go too deeply into it, we have UI scoped annotation here. We're using Vaadin CDI to create the views, and that means that we can inject the service, our database entry point directly into the view.
So we don't need to instantiate the service anyhow.
No, we can just
the CDI managed bean will automatically kind of inject a new instance from a pool of AGVs there automatically.
So let's take a look at how we populate the entries into a table. So we have our table here, entry list. It's a M table because we're using Viritin. It's a Vaadin add-on that you can download from the directory. But this is basically a Vaadin table component.
Yeah, pretty much the same thing would happen if you would use the basic Vaadin table.
So we have our table here, and we have our service here, so our database backend. And then we just have a list entries method here. So just a one-liner, service.getEntries with a specific string filter, and then that returns a collection of entries, and then we just call the table.setBeans method.
Yeah.
That's it.
So pretty simple.
Yeah.
So can you see the get entries? So the get entries method as well. I think we were already there, but
so the EGB that we're using, get entries here, what it does is it actually uses the repository that I just showed you. So if the filter is null, we just return everything. So entry repo.findAll. This is provided by Deltaspike. And then if there is something in the filter, we're using our own method, this find by name like ignore case. And then we just give it the filter here. And that returns a list of objects. And as you've seen, we haven't actually done this query. We haven't written any SQL or JPQL or anything, but this is actually just auto-generated for us.
Yeah, that's a good usage of JPA.
Yes, this is definitely the new recommended way to do it.
Yes. Okay, let's go to editing part. So that's the part where we would actually hit problems because you just put it to lazy loading these relational fields, so the groups and stuff like that. So what happens when you click on that row?
When I click on one of the rows in the table, what happens is that JPA, or we take this entity that we have in the table and then populate this form here. So each of the fields in our entity gets its own field. We have 3 text fields here. We have a date field, we have a Boolean switch here, and then we have a component that handles multiple address objects as well. And of course the groups. So if we change here, so I changed the last name for the object, we can save the last name of that person. And as you can see here in the table, it actually changed. And this now stored it to our database as well.
So let's go through this procedure in the code. So let's go to main view again. And there you have this form, and you will be accessing this in method called edit entry.
So when we have a value change listener on the table, and then we call this method and we get the selected entry. If the entry is null, we hide the form basically because we don't have anything to edit. But if we do have something to edit, then we do a couple of things. So first of all, we check if this object has been persisted or not.
So this is probably because the plus sign there, if you add a new person, then we can have like detached entity there as well, or new entity.
Exactly. So our table might have unstored or one unstored item as well, which is the newest one, which we just created. So it might not be saved still. But if it is, then we call service.loadFully, and this is in case of Hibernate. We'll talk about this a little bit later, but what this method is, it makes sure that everything in the entity is loaded.
Yeah. So if we have these lazy fields, then they can also work in the form.
Yes. And then we just set the buttons enabled, fill the form, and we're good to go.
Yeah. Okay, let's look at the loadFully method then in the service class.
Yep.
And this has lots of documentation.
Yes.
And it's pretty much talking about this lazy loading issue that one might, and what you probably have in your JPA applications.
Yeah.
Especially if you're using Hibernate. Eclipse is pretty actually.
Yeah, for some reason Eclipse Link is actually, for some reason I know exactly why, Eclipse Link is implemented a little bit differently than Hibernate. So Hibernate does not by default load these lazy lists on demand. It just throws you an exception, a lazy loading exception, which everyone who has used Hibernate probably is familiar with. But Eclipse Link is much better at handling this, and it can actually dynamically it's a little bit cheaty.
It can reattach the entity back to the session if it's a detached entity, and then
automatically populate it. So it's a little bit of black magic, but it actually works really well, especially with Vaadin applications. But for Hibernate, we need to actually manually go back to the entity manager, attach the entity, and then make sure everything is loaded. And then return.
And in many cases, you
version.
Also, even with Eclipse Link, you might want to use this kind of pattern because then you can save some queries. You can, instead of first fetching the actual edited entity and then finding the lazy loaded fields with a separate query, you can make them with one and only query with a join query. So that's the kind of the typical way to solve the issue. And our first case here as well, which is actually commented out.
Yeah, so there's this em.create query here. So as you can see, there's a select from phonebook entry left join fetch with the groups. So we're basically manually joining the two tables together. That's one way to do it. That's the way I would do it. But then there's
the old way to do it.
Yes. Then there's this entity graph that's new for me. So you can explain what you've done.
That's actually a pretty new feature because it was introduced in Java JPA 2.1. So entity graphs can they can describe different kind of strategies that I want these and these fields to be loaded. And there is a load graph, and then there is what is this other called? Is it entity graph itself? Yeah. So you can use this same entity graph object in both cases, but in this load graph case, it will kind of give you extra hint that load these lazy fields as well. But you can also use entity graph in such a way that it will only load the explicitly added fields there. So you can actually make your queries more efficient so that it doesn't load everything. If you know that you only need, for example, name and the phone number from your entity, then you don't need to load the email address at all.
Yeah.
And it will save some memory and some database capacity as well.
Interesting.
So practically here we are just creating this entity graph, and then we are using a Deltaspike data helper there to give the hint there.
So this is our repository, and then we use the find by ID method. We provide the ID for the entity, and then we give it a hint apparently here.
Yeah, practically if you're using a raw JPA API, you can also pass that to entity manager in create query, and there you have the last parameter is a map, and there you can give the same kind of map there with multiple hints, and this is just one hint that you can keep there.
Or then the third method, which we actually use in projects, please don't hate us. When you have attached the entry, you can call the collection and then you call size on it, which actually also loads everything properly.
So because this is a method in an AGP, so the transaction is still open, and inside here you can actually, if you somehow access the fields, then it will cause it to load.
Yeah, exactly. So for instance, if we're using Hibernate and this would be normally lazy loaded collection, then up to this line, this collection is actually a proxy. It hasn't loaded the object itself. It just knows that there should be some objects here. And then when we call size, it actually has to populate the collection to know the size. And as a byproduct, you get all the correct entities in place. Yeah. So it's a very nice one-liner. It doesn't make much
it looks
sense
like
when you look like it like this, but it actually works pretty well.
Yeah, and it's throughout the industry, I think it's the most commonly used way to bypass this lazy loading issue.
Yeah. So if you don't need to worry about how the entities are loaded, so you don't have to do the queries yourself or do optimization on the fetch queries.
Yeah. This only causes one extra query in this case.
Yeah, but in more complex scenarios, it might do something a little bit strange that you don't want to. So then you can use these other ones.
Yeah. Okay. That's about loading it for editing, but what actually happens when you save it?
Well, let's take a look. So in our main view, we have this entry saved method. So the form, when everything is filled and validated and the user presses store, then we get to this method. And here again, we just call the service. This is our EGB now. And we call the save method in the EGB. And if that succeeds, then we just close the form, and then we
refresh the list.
Yeah, we refresh the table basically. So this entry list is the table. We select null in it, and then we just refresh everything so that we have the new data in the table. And
there you actually have also this try catch clause. So this is where you have this optimistic locking. So this relates to this version.
Yeah.
So
we'll get back to that in just a second, but a quick see through how the save method works first. We're using the JPA the Deltaspike data repository, so we just call save.
Yeah, that looks pretty handy.
Yeah, so there's the same thing for the phone book group just below here. So if we were using pure JPA, we would need to use the entity manager, and this is how we would do it in that case. Yeah. There's actually two different methods for saving an object depending on if it has been saved before or not. Yeah. So if it hasn't, we use persist, and if it has, then we use merge. But the entity repository does the same thing for us, and it's auto-generated, so it's easier to use just the one line. Yep. Don't need to worry about things. But yeah, so why do we have a try catch here? Well, a couple of reasons. The primary reason why this is here and not, for instance, in our service is that we're using JTA, so the automatic transactions. And the way we're using them here means that the transaction starts when we call the save method and it ends when the save method is exited. Yeah. So we're not actually in a transaction in this method here yet. This means that this is our transaction boundary and any exceptions coming from within the transaction will bubble up here.
Yeah. So we'll have to handle them, or we should handle them here.
We should.
Otherwise, you will just get this nasty little mark in your save button.
Yeah.
That's not that
so
cool.
Remember, every time you access EGBs, just wrap them in a try-catch and then handle the error somehow.
Yeah.
We don't really care how, but handle them at some way. Just show a notification to the user or something.
Yeah.
But yeah, the comment here, most likely optimistic locking exception. JPA can throw lots of exceptions, different sort of exceptions. If your database connection, for instance, disappears, then you'll get an exception. But most typically what happens in a multi-user environment like with Vaadin is that two persons are working on the same entity at the same time.
Yeah.
And now we come to the
version tagged field.
Yes, the version field. So let's go quickly back to the phone book, or actually the abstract entity class that we have. We have this version field that's an integer that we also do not populate at all. Concurrency is a big thing, and there's also books written on that actually. But the very simple version is this. In Vaadin applications, you have multiple users working on the same database. They might be working on the same exact object. So what should happen if one user or two users open the same object and one user stores the object and then the other user actually tries to store the same object with different data? They might not know that the other person was modifying the data. So there's a couple of different strategies that you can use here. One, you can ignore the error and just let the one who stores it the last get the correct solution. So basically we lose the changes that user one did. Or the second one, you can choose to handle this somehow. And there are different ways how you could use that, but we recommend optimistic locking in most cases, and that's what this version tag here is. Every time you save an entity with optimistic locking, JPA automatically increments this version number for you. And then when you try to store an entity, it also checks the version number of the entity that you're trying to store, so making sure it's the newest version. Yeah. And this means that when two users are interacting with an entity in the way we described, then you actually get an exception for the second user because the data was already changed and now we have a new user who's trying to change data that was old.
Yeah. We can probably actually try it out with
Yeah. So let's reload this and then select the first one. So Carly Copeland here, and Carly is automatically populated into the form. So let's open this up in a new tab and we have the same situation. So we have two tabs.
Now try to call Carly Matti.
Yes, with the same thing. So let's start. User one is using this first version and they are renaming this person to Matti Copeland and saving it.
And now try Thomas for the other tab.
And now let's go to the other tab and write Thomas and press save.
Matti won.
Yeah, Matti won. So you can see that the changed data here is now Matti Copeland and the notification says that there was an optimistic locking exception. Yeah. So now as a second user, I know that, something went wrong and I actually have to check the new data that someone else made and then maybe change it again if I need to. Or I might notice that, someone already changed it, so it's correct now. I don't need to do a thing. Handling these sorts of errors are a big part of any enterprise application and they're well outside the scope for this webinar. But
just so like one simple recipe to handle this.
Yes, but just so that you know and that we mention it, optimistic locking is definitely the way that we recommend handling these sorts of things. So using a version field, letting JPA handle the version field and then just handling the optimistic locking exception when that actually is thrown.
Easy way to do it.
Yes.
So we have deleting still missing from the CRUD functionality. So what happens there? Pretty much the same thing.
Yeah, we have this delete button here. So when we press it, the entity is removed, and we can see the code for that. If we go to our service, there's this delete method here. So again, 2 different versions for our 2 different entities. When we remove a phone book entry, we can actually call the repository and remove the entity like this. And then for phone book group, we use the entity manager. But there is a little bit of gotcha here. JPA has this peculiar, this small feature, let's call it, where you actually have to have the most recent object, and it has to be attached to the session for you to be able to delete it.
Yeah.
So basically what we have to do is we have to find the newest version of the entity and then delete that.
Yeah, exactly. Kind of have an attached entity that you remove.
Yeah, and Deltaspike data doesn't actually help you with this either. It's a design
maybe
decision.
It should.
It should. I think it should, but
or maybe they should have some remove force method.
Yes, something. Yeah. Well,
let's
anyway, JPA will tell you if you're doing the wrong thing. So it will tell you that you're trying to delete a non-attached entity, and then you can, you have to do this. So using the entity manager instead. So no. The old manual way, we have to do basically the same thing. So first we find the newest version using the ID, and then we call remove, which is basically exactly the same thing that this method does.
Okay, I think we now have the basic usage covered, but the first thing that our users usually face, and what was actually also used as a question there for a couple of persons at least, is that how do you use the lazy loading thing? That's kind of a solution where people typically throw it in the JPA container, and that caused some other issues. And so what's the way to do that? And I can actually show you the impact of wrong kind of queries here. At this point, we had this application in a state that it loads all the entities from the database. We just used the find all method there. And if we look at the init method here with xrebel, we can see the find query here, list entries. And it's a one single query. It's pretty fast at this point because we don't have that much stuff in our database. We have 200 rows by default, but it's loading all of them. If you would have 20,000 rows in your database or 100,000 rows in your database, this would cost something like...
It would still load all of them.
Yeah, and it would use something like 100 megabytes of memory or something
I've seen that in multiple projects where I've been consulting, and it's a very typical issue.
Yeah. It might work in your development environment where you don't have that big database, but in a real life application where your database grows, it will become a problem at some point.
Yeah.
So let's fix this issue. In this case, we have prepared this example here. So we will just change the list entry strategy to different kind of thing. So instead of finding them all from the service, we'll use a lazy loading strategy. And here we will call service with 2 methods from Lambda expressions. And this actually uses Vaadin add-on. So this is why we had this end table there. So it has a quite sophisticated way to do kind of lazy loading from different kind of backends. It doesn't need to be JPA, but it can be JPA repository where you access the objects. So you practically, let's actually change this to inner classes, so you can, as a Java developers, maybe understand a bit better what happens. So we will give 2 different kind of strategies for the table. So first one is how to find the entities and from which row on, and the other one is how many rows are there in the table. And with these two strategies, the UI can actually find the rows that are actually visible in the UI. So in this case, that would mean that only this part that is visible here in the UI needs to be loaded. But it actually loads a bit more than that for some cache, but it doesn't load the whole 200 rows. So if we now save the actual code and wait for the JREPL to load it and reload it, we should see like a much faster or much more efficient database queries here. So this is the same list entries method, but in this case we now have like 2 queries instead of 1, and the one that's executed first is the count, so it needs to estimate the number of entities in the table so it can like fake the scrolling there.
Yeah.
And then it will make 1 query to the database, and it only returns 45 rows. And if we go to the browser,
less than 1/4.
yeah, and scroll down, it will go to the database and make another fetch to the data.
Yeah.
And
so some of you had the question of how to manage huge data sets, and that's like this. So
yeah,
by default, the Vaadin table and grid components and the combo box are lazy loading, but it's only from the client, so the browser, to the server.
Yeah.
You still need to have everything loaded on the server.
Exactly. So this kind of extends the lazy loading chain up to the database.
So all the way to the database, and we're basically using a lazy loading mechanism all the way and just loading the data that we actually need.
And it actually uses quite a lot of less memory already. It had something like 200 kilobytes per session, and now it's only 130.
Yeah. So if you're having problems with huge data sets, then
it doesn't have to be the memory that's first the issue. No. It is most often actually more the slow database queries, because you will be returning so many instances from the database.
Yeah. And then JPA has to transform those into objects, and
exactly. It will have to convert all of those rows into objects, and that's a costly thing to do.
Yes. So that looks great. Where can I find that code?
You can go to for the application, demo application, or
for the lazy loading.
For the lazy loading, yeah. This is using Vaadin, so you can go to vaadin.com/directory, and you will find Vaadin from here, and then you will also have, there was this older which is pretty much in use still. I think you are still using this one in your application. Yeah. Lazy
lazy query container.
Lazy query container, that's the way it goes.
And you don't remember it since you're not using it anymore.
I'm not using it anymore. Yeah, so this was the old solution, but it's still just valid as well.
Yes, exactly. So nothing wrong with that, but Vaadin is slightly simpler nowadays.
And I would say that it's actually slightly more efficient as well, because it's using a bit less memory. Yeah. And somebody actually also asked how you can do this with the new grid. And you can actually use this container alone. We are using the M table here, but behind the scene it's using a different kind of container, and you can use that with grid as well. And there is now, in latest version of Vaadin, there is M grid available as well, which has the same lazy loading strategy as well. Okay. And with the lazy query
container works out of the box with the grid as well.
Yeah. Okay, so shall we go through some other questions? We have like 2 minutes until 1 hour, so we can maybe
quickly go through some.
Yeah, let's take like 2 questions. So Lucy is asking, what's the best implementation for Vaadin? So that's the JPA implementation.
Honestly, it doesn't really matter.
Yeah.
I would avoid Open JPA myself. I've had some bad experiences a couple of years ago, but Eclipse Link or Hibernate doesn't really matter at all.
With Eclipse Link, you might have like a bit
Hibernate has
experience with lazy loading.
The small issue with lazy loading, but if you know how to handle it, then it's not a big issue. Eclipse Link, if you want the really trouble-free experience, but Hibernate is just as good, in my opinion.
Yep. And then Roman is asking about difference between Spring Data JPA and pure Java persistency API in Vaadin UI projects.
Yeah. Well, the same thing can be expanded to pure JPA or Deltaspike data as well. So
Yeah,
as you
or
can see,
Qr Diesel, which is
Yes,
also
exactly.
kind of an extension to JPA.
yeah.
that
So
you-
as you could see here, you can use just pure JPA. Nothing wrong with that, but I would really recommend using one of the helper libraries for you. They're made for a good reason. They're really awesome actually to use. We use them in all our projects here, and they help, or they just save time basically. You don't have to write a lot of code, you don't have to debug your own boilerplate, and it just helps you out a lot.
Yeah, I actually had a presentation in Java 1 about Deltaspike data and Qr Diesel. I have really became a fan of these products, so please use them. What should we do next? Guilherme?
Guilherme asked that he feels that there's little space between the database and presentation layer if you're using JPA and Vaadin. So he says that it works great if you send the data from database directly to the UI. We're assuming that you've been using the JPA container from the wording of your question. Me and Matti and everyone here, we suggest that you actually use something in between.
Yeah, exactly as we did in this example.
Yeah. So the JPA container.
Yeah,
I'm just gonna go out and say that please don't use that in real projects or big projects. I'm not a big fan personally. We always have some sort of a middle layer in between, be it Spring, Beans, or EGBs or anything. There's always a middle layer there. So you always have somewhere to put business logic. You have somewhere to put validation.
Exactly.
Data fetching, query optimization, stuff like this, and that shouldn't have anything to do with Vaadin.
Yeah.
And then you just have a unified API that you call from your Vaadin application. And that's the way you really should do it. And a couple of examples here in our demo app on how to actually use it using EGBs. This is very similar to a lot of our real projects.
Yeah, and it doesn't make your application that much more complicated than if you would be using JPA container. So you will have to learn JPA anyway, so why not make it in the real way?
Yes. Very true.
We have lots of other questions that were asked, but we are running out of time, so we will stop here. Or let's make it so that if some of your questions didn't get answered in this webinar, you can still ask those in the thread, and we can try to monitor it for the next week a bit more.
And we'll get back to you.
Yes. Yeah. Okay. Thank you.
Till next time.